All right, we have this question here. The roots of the equation 3x squared plus 4x minus 5 as 0 are alpha and beta. Find the values of the following. All right. So the first thing that we do, all right, we've got this is a quadratic equation. All right. So we have to get our A, B, and our C. What are those? A represents the coefficient of x squared. So the coefficient of x squared is 3, right? The coefficient is just a number that comes before a variable. All right, so the coefficient of x squared is 3, right? B is the coefficient of x. Just a small letter, right? And the coefficient of x is 4, all right? Then C represents the constant. A constant is just a number without a variable, right? Without a letter. So it says C is our constant, right? Equals -5, right? Before I proceed, any questions or queries? Right? Because remember, the format of a quadratic equation is ax squared plus bx plus c. Right? So, in order for us to obtain our roots, right, our roots, which the identities which are alpha plus beta and alpha times beta, all right, we need first to get our the coefficient of x squared, the coefficient of b, and the constant. All right, because if we remember, alpha plus beta, alpha plus beta equals negative b over a. Then alpha times beta space. Alpha times beta equals c over a. All right. So that's why we're getting the A, B, and C's for this alpha plus beta and alpha times beta. All right. So now we're going to have to replace our B. This here, our B, negative B, we replace it with negative 4. And our A, which is here, we replace it with 3. So we'll say for alpha plus beta, we just put it here. Right, for alpha plus beta, it's negative B over A. Right, so our B is 4, so we say negative 4, right? And our A is 3, so we have negative 4 over 3. This is our alpha plus beta, negative 4 over 3. Then the next one, our alpha times beta, It's C over A. So our C is -5, and our A is 3, -5/3. All right. So before I proceed any further, are there any clarifications, questions? Right? Because this is the first thing you do when you're answering these questions.
Hello?
Yes.
Can you go through the process again?
All right. The first thing you do, all right, you get your coefficient of x squared. Coefficient is a number that comes before a variable. The variables are just the letters, all right? So you get your coefficients and your constant, all right? So a, which is the coefficient of x squared, you list it down, it is 3, all right? The coefficient of x squared is 3. B, which is the coefficient of x, you list it down, it is 4, right? Then C, which is our constant, a number without a variable or a number without a letter, right? Write it down as, excuse me, -5. Once you have obtained these coefficients and this constant, all right, this is always standard, all right? Alpha plus beta equals -b/a, and then alpha times beta equals c over a. So after you have found these coefficients and the constant, you replace into these, right? As you can see here, alpha plus beta, -b/a. B is 4, so put -4/3. Right, our A is 3. Then alpha times beta, right, which is C over A, C equals -5, right, and A equals 3. Is that okay?
Yes.
Or has it left you with more questions?
No.
Okay. All right, so we're going to start with our first one, 1 over alpha plus 1 over beta. All right. This one is definitely coming on your quiz. All right. 1 over alpha plus 1 over beta. That's the first thing we're doing. All right. So this 1 over alpha plus 1 over beta, we're going to solve it just like the way we solve fractions. All right. We find our common denominator. Our common denominator is alpha beta. Okay. That's our common denominator. All right. So we're going to say alpha beta. All right. Divided by alpha, we get beta. All right. So we put here beta. All right. Plus, right, alpha beta divided by beta, you get alpha. All right. So we can rearrange the numerator. Right. Just admit someone in. Thought I had someone trying to log in. All right. We just rearrange the numerator. All right. We just put it as alpha plus beta. right? Then after that, we're just going to substitute, right? Because we've already got our alpha plus beta, which is negative 4 over 3. All right. And we've got our alpha times beta, which is negative 5 over 3. All right. So in your exams, you have to make it look neat. All right. First, you just rearrange. Yeah. Yes. So now here, this is where we can just do the rearranging. Okay. So we're going to say alpha plus beta, right? Alpha plus beta is negative 4 over 3, right? Negative 4 over 3, right? Divided by, all right? Yes.
I don't know if it's possible for you to use the other board that you write so that I can understand how you've rearranged it. It's a bit hard to follow the typing.
Or you prefer the board?
Yes, please.
Okay, let's just hear from our fellow colleagues. Do we prefer the board?
Yes, sir.
Okay.
Yes. It makes more sense if you use the board because like that tumaoneka mwanga mtakatoli dot.
Okay. I thought Microsoft Word was the preferred one. Okay. Thank you for giving me that notification. All right, so let's switch it to the board. All right. Right, 1 over alpha beta, the common denominator alpha beta, right? Alpha beta divided by alpha, you remain with beta. Then beta divided by alpha beta divided by beta, you remain with alpha, right? So since we have it's written as alpha plus beta equals negative b over a, so here in our numerator, right, we just rearrange them, right? We just bring the alpha in front plus beta, right, over alpha beta. Okay, that's when you can substitute, right? Because If you just leave it like this and then you substitute, you might lose a mark, okay, because the identity is saying alpha plus beta, not beta plus alpha, right? So you show that you've rearranged it, right? What was our alpha plus beta? It was, let's see what our alpha plus beta was. Negative 4 over 3, and alpha times beta is negative 5 over 3. All right, so we have negative 4 over 3, all right, divided by negative 5 over 3, all right. So what you can do here, okay, just put it like, rearrange them as you're dividing the fractions. You say negative 4 over 3 divided by negative 5 over 3. All right. Remember, when you are dividing fractions, the sign changes. The division sign will change. It becomes multiplication. All right. And when it becomes multiplication, this 3 will go on top, and this 5, this negative 5 will come below. All right. So it's negative 4 over 3 times negative 3 over 5. All right. I mean, 3 over negative 5, sorry. 3 over negative 5. But either way, it still makes this negative. All right. It still makes it negative. All right. So these 3's will cancel each other out. All right. And you have there negative 4 over negative 5. All right. And then negative and negative make positive. So your answer is going to be 4 over 5. All right. So that is your answer.
Hello, sir.
Yes.
On the negative 3, I just want to know how the negative has carried the 3 has carried the negative sign.
I said 3 over negative 5. All right. If you want, you can leave the negative down. All right. You can leave it down or up.
Okay.
Yes.
So I've just joined you, so maybe at a certain time you can go through from the beginning so that I catch up.
From the beginning.
Yes, sir.
Okay. First, before we reach there, are there any queries on what we have done here? Are there
Yeah,
any?
up to where I found it, I think I'm okay. But how you came up with the formulas so that replacement is not a problem.
Okay. Always remember alpha plus beta equals negative b over a. Okay. You always have to remember this. All right. Then alpha times beta is c over a. So these a's and b, these a, b, and c here, these are just representing, the a and b are representing the coefficients of, in this quadratic equation. All right. They're representing the coefficients. Then b represents the constant. All right. Right. So whenever you say quadratic equation, that's the format. All right. Yeah. Mr. Joachim, so yes, after you do that, you determine your A. A is the coefficient of x squared, which is 3. B is the coefficient of x, which is 4. And C is the constant, which is 5. So that's how we've replaced here.
Okay, I understand.
Okay. So remember, that's what you should do whenever you're solving these roots of the equation, right? Right. So if there are no questions, I can move on to the next one.
So I have a question.
Okay.
I understand how I can replace the figures in the numbers in the symbols, but from 1 over alpha plus 1 over beta, and then that next part where there's the B on top and the bottom. Yeah. Yes, that part, please. How did you get to that?
We find our common denominator, which is alpha beta. Okay. So after you find your common denominator, you're going to say alpha beta divided by alpha, you get beta. All right. Then the next one you say alpha beta divided by beta. Okay, you get alpha. That's how we got these ones there. It's like you're just solving a normal fraction. Okay. Okay. Are there any other questions? We proceed to the next one.
Sir, I think it's clear.
Okay, wonderful. Wonderful. All right. The next one is alpha squared plus beta squared. All right. So this is where you have to remember the identity. All right. If you don't remember, right, this is when you have to derive so that you can find the identity. All right. So the identity of alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. All right, this is the identity. Once we're done with the equation, we'll see how we derive these identities, because it's not always good to memorize. You might forget one, might forget. All right, but this is the identity for alpha squared plus beta squared. All right, so here we're just going to substitute. All right, alpha plus beta, that is negative 4 over 3. Squared, right, minus 2 times alpha beta is negative 5 over 3. Right, negative 5 over 3. All right, we square it. Negative 4 squared, that is 16. 3 squared, that is 9. All right, negative 2 times negative 5, that's positive 10 over 3. All right, this negative and this negative make it positive. All right, our common denominator here, it is 9. 9 divided by 9, that is 1. 1 times 16, that is 16. Plus 9 divided by 3, that is 3. 3 times 10, that is 30. All right, then I hope we've written this answer down here.
Yes, sir. Repeat where you started 16 over 9. How you were finding this. Just repeat, sir.
Okay. We square, all right? This negative 4 over 3, we square it, right? So negative 4, right? You square them individually like this, all right? So negative 4 squared is 16. Negative 4 times negative 4 is 16. 3 squared, that is 9. Okay. Then here we have minus 2 times negative 5 over 3. Right? So you say negative 2 times 5. That's how we get positive 10 over 3. Right? This negative 2, we multiply it with this numerator to get positive 10 over 3.
Clear, sir.
And now I was asking, have we written these solutions down or taken a screenshot? Because I want to erase so that I give the answer here.
Erase. Yes, sir.
Okay. Remember, don't swatter the answer. Okay. If it comes, actually no, you have to actually swatter the answer so that when you're solving and you find you don't get it, then you know you're wrong. So 16 plus 30, 46 divided by 9. All right. We can simplify this. All right. This is an improper fraction, so we can simplify it. All right. 46 divided by 9, it is 5, remainder 1. All right. So that is our answer there. All right. 5, 1 over 9.
Hello, sir. Where you found 16 plus 30 over 9? What did you do? You got the...
I added the numerator.
Right. You added
This is the numerators.
Okay.
Yes, that's how we got 46 over 9.
Sir.
Yes.
Sir.
Yes.
I'm not clear, sir.
I'm saying you.
Sir, where you, sir, she's saying where you found the common denominator and then, which is 9. Then 9 into 9, it's 1. 1 times 16 is 16. Then 9 into 3 into 9 is 3. 3 times 10 is 30. Then 16 plus 30 gave us 46. That's why obviously she's trying to add.
Oh, you have explained it. You have explained it for me.
Thank you. Very clear. Thanks.
Wonderful.
Hello,
First, let's clap
Hello,
first before Mr. Benjamin. Wonderful
Yes,
for that explanation. Mrs. Chinza, wonderful. Thank you for that explanation.
Thank you, sir.
All right. So even
I'm still behind, sir.
how?
After just on how you found number negative 2 alpha beta. I was kicked out. I was too. So by the time I was brought back, I found that you have already written this one.
Okay. So, as I said,
Mr. Benjamin, I thought you're in Lusaka. No, we're still struggling with network.
My brother of mine.
You're still okay. This I was saying that this alpha squared plus beta squared, its identity is this, all right? You have to remember this. If you don't remember it, you can derive it for yourself, okay? In your yes, in your exams, you won't have to derive it, all right? In your exams, you just derive it on your workings on the rough paper, then you put it in, okay?
Now, what happens if I try to drive it myself and then just?
Oh, if you show it on your working where you have derived and everything.
Yes.
I guess you might get an extra mark, or the examiner will just say that okay, she put in extra work, but yeah, but you're not required to. Okay, you are not required to. What you're just supposed to put is the correct identity, then you solve. All right. You have to. So if you do that, you show the workings. You just show you have understood. You've really understood that topic, but I doubt.
And then my question is now, if it's alpha cubed plus beta cubed, what will become on what number will be on -2?
That's the next one we're going to look at. Alpha cubed plus beta cubed. So before I go to that one, are we all clear on this one?
Yes.
Okay.
Crystal clear, sir.
Okay, that's good. I'm sensing 100%. 100%. All right. The next one is alpha cubed plus beta cubed. Let me just erase here. Okay. All right. Alpha cubed plus beta cubed. Right. Then its identity is alpha plus beta cubed.
Sir,
Yes.
I'm asking maybe if you can remove these other things that you erase them.
Okay. All right. Yeah, the board shouldn't look too scruffy. All right, I think like this is much better. I believe we've written down this answer here. Can you also erase it?
Yes, sir.
Is it a no or yes?
Yes, sir.
Okay, wonderful. Yes, so the identity is alpha plus beta cubed minus 3 alpha beta, open brackets, alpha plus beta. Let me just check on my list so that I make sure that's the correct one I've put here.
It's correct, sir.
It's correct, huh?
It is.
Okay. All right. Okay. Then here, it's just a game of substitution. So our alpha plus beta, which one is it? It was -4/3. -4/3 cubed minus 3 times alpha times beta. What was that again? Alpha times beta. That was -5/3. All right. Then times alpha plus beta. So that's -4/3. Okay. So we do this step by step. All right. So -4 cubed. That should give us. Anyone the calculator? Let me look for my calculator. -4 cubed.
-64.
-64. All right. -64. And then Negative 3 cubed 27. All right, so we have negative 64 over 27. All right, so here we say negative okay, first we'll do with these two fractions here. Negative 5 times negative 4, negative 5 over 3 times negative 4 over 3, we're going to get 20 over 9. All right.
You do the brackets first.
Yes. Although, yeah, and although these I wouldn't say that, it's just here mostly it's just like I'm saying 3 times negative 5 over 3 times negative 4 over 3. The brackets here, I'm just trying to separate, just trying to show that, just trying to separate them. All right. But the way it should look on your paper is like this: negative 3 times negative over 3 times negative 4 over 3. Okay. Because you're multiplying 3 and times alpha times beta times alpha plus beta. So it's simpler if we work with the fractions first. Negative 5 over 3 times negative 4 over 3. We get 20 over 9.
15 over 9?
Huh?
Why isn't it 15 over 9?
I'm working like this. I'm now multiplying by 3. If you want, you can work this way. You start negative 3 times negative 5 over 3, you get negative 15 over 3. Negative 15 over 3 times negative 4 over 3, you get 60, negative 60 over 9. Right? You can work either way. So I'm working with the fractions going like this. Right? First I multiply the fractions, then I multiply it by this negative 3. Okay. Equals, all right, negative 3 times 20, we get negative 60. So we have negative 64 over 27. Okay, over 27 minus 60 over 9. All right. Common denominator 27. Divided by 27, that's 1. 1 times negative 64, we get 64. All right, 9. 27 divided by 9, that is 3. 3 times 60, we get 180. So we say minus 180. Negative 64 minus 180. This is going to give us negative, what is 180 plus 64? Now I have to start doing addition here.
244.
244, huh?
Yes.
Okay, so negative 244 divided by 27. All right. We have to make it a proper fraction. Let's see which number is closest when we multiply it with 27. 244 divided by 27. So 27 times 8 to 60. 27 times 9. All right, so 27 times 9 is 243, all right? So if we simplify this, all right, this negative 244 over 27 is going to give us, all right, 27 times 9, that's 243. So we have 9, 1 over 27. Yes, this is our answer.
Please explain from -3. I've not gotten what you did exactly.
Okay. Think of it like this, okay? In a simpler way to be like this. 3 times 20 over 9, that is 60 over 9 here. All right, and you have a minus sign here. So negative 64 over 27 minus 60 over 9.
So where I'm lost is, I understand that you did -3 times -4 to get 20, then -3 times 3 to get the 9. That's how you got 20 over 9.
Which one?
How did you get -64 over 27?
We cubed this, negative 4 over 3.
Okay. Hello, sir.
Yes.
Sir.
Yes. Excuse me. Yes, you may ask your questions.
Sir,
Yes. Oh, the answer has to be negative here, because yes.
is it supposed to be negative there?
Yes, I forgot to put the negative sign here.
Excuse me, sir. Maybe we multiply again. Where is 3, like what the lady has been saying? 3 multiplying by, in the brackets, -5 over 3, and then again times 4 over 3 in brackets. Let's go through that arrangement again.
Okay.
Yeah.
We Google it. Okay. All right. 3 times -5 over 3, that is negative 15 over 3. All right. Then negative 15 over 3 times -4 over 3, that is positive 60 over 9, which is here. So you can work either way. If you want to work like this, whichever suits you, or you can work backwards like that. Either way, you still find the same answer. Are we okay? Were there any more queries?
Yes, sir. I think